Let us use the decision zone mapping technique in the face of uncertainties. A World Health Organization study indicates that there is a 75% likelihood of a flu striking the USA next year. This would have a significant impact on productivity. A government committee is considering 3 options to manage the situation. Option 1, vaccinate the entire population of a particular city. Cost $7 million, and the program is assumed to be 100% successful with no additional treatment costs. The second option is not to vaccinate, but the associated costs in terms of loss of productivity if the flu strikes is $5 million with a 30% probability, $10 million with a 25% probability, and there's a 45% probability the loss would be as high as $15 million. The third option is to establish an early warning monitoring system. This would cost $3 million, and that would give a better idea of the likelihood of an outbreak. And then, based on the results of this monitoring, the government can decide if they wish to conduct a rush vaccination program before the outbreak spreads at a cost of $8 million, of course, with a guaranteed 100% success. Let's draw the decision tree first. As you can see, we have 3 options: vaccinate, do not vaccinate, and early monitoring. If you do not vaccinate, there is a probability of the flu striking, and there's a probability that the flu would not strike. If the flu does strike, we have a low loss situation, a medium loss, and a high loss. Likewise, if we set up an early monitoring system, there could be the situation of no flu and flu. And at that point, we can decide whether we wish to rush vaccinate or we do not wish to vaccinate at all with the associated losses. So this is our decision tree. Now we can model this on Excel. Here we have the Excel model, and I have shown here the 3 options: vaccinate, early monitor, and do not vaccinate. Here's the case where the flu strikes. Let's look at the D zone. Here is the D zone map. The horizontal axis represents the probability of flu striking, and the vertical axis in this case represents the probability of high losses. The map is divided into 2 segments by this demarcation line. Above the line, the recommendation is early monitoring, and below the line, the recommendation is do not vaccinate. Since we have the diamond pointer in the early monitoring segment, the recommendation is to early monitor. And what is important is to notice the distances, vertical and horizontal, where we would see the degree of latitude we have in terms of our assumptions. As you know, these probability assumptions are actually guess estimates. What this chart shows is that even though we start at a 70% assumption of probability of flu strikes, even if the probability is just 60%, we should continue with early monitoring. It's only when this diamond pointer crosses to the other side that we should actually consider do not vaccinate option. The decision is to do not. So what this says is that decisions that deal with probabilities need to be handled through modeling. To attempt to use pure common sense would probably bring disastrous results. For more information, please write to us at author@expertus.com. Thank you.